This video is one of the lessons that I'm creating on KBTrainings.com to help you prepare for the Cisco CCNA 200-301. So if you are trying to get the certification that can help you start or boost your career in the IT or networking, go on KBTrainings.com/CCNA and you're going to find the course, and I'll see you there with the complete course that I'm creating. Hey, what's up guys? This is Guy here with KBTrainings. Welcome to the lesson number 3.4.4. We are still talking about Ipv6, and today we are going to cover Ipv6 static routing. As we can see in the exam blueprint here, under IP connectivity, Cisco is asking us to know how to configure and verify Ipv6 and Ipv4 static routing. So we're going to cover all these different points here. So by the end of this lesson, you will be good with this. In the past few lessons, I introduced Ipv6. I also talked about the different types of IPs that you can have with Ipv6, and I talked about Neighbor Discovery Protocol, or NDP. So today we are going to introduce Ipv6 routing, which is not far from Ipv4 routing. I'm going to say a little more on static Ipv6 routing itself, and we are going to talk about default route, network route, host route, floating static route, and of course, as always, at the end I'm going to finish with this packet tracer lab here, where I'm going to configure these different devices in order to communicate. So we'll be able to ping from here to these two devices, or these two devices can be able to ping each other as well. So that's what we're going to do at the end. As always, a lot of practice, a little bit of theory. I mean, we need theory to know what we're doing, but this is tech, so you need to practice to build the muscle memory that you need to become a good engineer. So we're going to spend a lot of time in packet tracer here. All right, so to get started, what is Ipv6 routing? First of all, routing is the process of redirecting or guiding a packet from a certain network to a different network. And those two networks can be next to each other. Like if you are on a LAN, for example, you may have multiple networks in a single LAN, or in a WAN or wide area network, you can have two networks that are separated by many other networks. Let's say we have our office here in, let's say, New York, and we have another office in LA. So we have a service provider or an ISP that's going to give us connectivity to get to our office in LA. So these different routers should be able to guide or redirect our packets from network to LA and back. So that's the routing process, and we have different ways that we can figure out how to guide this packet from the origin to the destination. So when it comes to Ipv6, you need to know that it's disabled by default on Cisco devices, at least for most of their models or iOS versions. So you need to enable Ipv6 routing if you want your router or your layer 3 device to do Ipv6. So you do that by typing this command. You go under the config mode and you do Ipv6 unicast routing. This is all you need. Your router is then ready to route Ipv6 packet. If you don't do this, you're going to run into trouble. When I was preparing this, I did some lab where I forgot to enable this in one of the routers, and I couldn't do anything. I mean, I had to track the issue, and I found out that I didn't activate Ipv6 routing on a certain router. So this is something very important. We're going to do it in the lab. And with Ipv6, as with IPv4, we have many ways of knowing where to send the traffic. First of all, we have networks that are connected. When we are directly connected to a network, we know that if we send packet through that interface, it's going to get there. That's one way. The other way is knowing statically, which means that you configure manually in the router or whatever layer 3 device you have, you configure the device to know exactly where to send the traffic. One other way is dynamically, using a dynamic routing protocol. We've seen routing protocols with IPv4, but as I showed you, for the scope of the CCNA, we don't have to see dynamic routing for IPv6. That's for the CCNP or any other next certification that you're going to take. But for the CCNA, we are going to talk only about static routing with IPv6. So talking about static routing, what is it exactly? As I said, it's when you configure manually the route to get to your destination. It's a good practice. It's being used pretty much anywhere, a lot, by service providers, by companies, and so on. It has some benefits and some downside as well. One of the main downside is that you need to keep track of your static routes, because if there is any change in your network, your static routes are not going to be updated automatically. So you need to go manually and update them. If you are there to realize that there is a problem, you can clearly, fix it. But if you're not there, it may create some issues. And the benefits of IPv6 static routing is that you have security, because when you do dynamic routing, you are connecting to other routers, and those routers are sending you routes, and they tell you, if you want to reach this route, send the traffic to us. But sometimes you can have a rogue router or a hacker on the other side that's going to create a session with you and send you routes that are false, so you can send all the traffic to the hacker or the rogue equipment. That cannot happen with static routing, because static routing, you assume that we assume that you know exactly your destination, and you know the next hop, and you are connecting to it. But there are mechanisms that are put in place to add some security, like authentication. Most of the routing protocols have authentication built in, so you can set up a password that you need to configure on both sides before establishing a session and exchange route. We also have resource efficiency, which means that with dynamic routing, you have a lot of calculations. You have a lot of traffic being sent back and forth between the devices to know exactly what is the best route to the destination. But with static routing, there's nothing going on. You configure it, it's there, it knows where to send the traffic, and that's it. We don't have, like in OSPF, we have the Digitra algorithm that is supposed to run, when there's a change, when there is something happening. That can consume your CPU, it can consume the memory on your device. But with static routing, there is none of that, so which is a good thing. And again, I said one of the downside is that you don't have automatic reconfiguration with static routing. One other thing that I want to mention quickly, it's not very important, but I want you to know it because it's in the documentation. We have 3 types of static routing. The first one is directly attached static routes. These are the routes that are configured on the device with a specified outgoing interface. Like in this case here, you do IPv6 route, you give the network or the prefix that you want to reach, and then you specify the interface where this traffic can be sent. This assumes that the destination is connected to this interface. So this is called directly attached static routes. We also have recursive static routes. This is when you specify the next hop. Instead of the interface, you specify the next hop, and the outgoing or the egress interface is going to be determined based on the next hop. So in this case, we have IPv6 route, we have a prefix, and then we have the next hop, and the router itself will figure out what interface to use to get to this next hop. The third one is the fully specified static routes. These are the routes where you specify the outgoing or the output interface as well as the next hop. This is mostly used when the interface is a multi-access interface, so it has access to many equipments. So you can specify this to say, hey, you can send it here, but this is the next hop. In our case, we are going to use only recursive static route, as you're going to see. So we are going to specify the destination as well as the next hop to reach the destination. As I said, this is not really important. I don't think it's very relevant at CCNA level, but at least you know it now. All right, let's talk about IPv6 default route. This is the route where a router or layer 3 device sends all the traffic for which it doesn't have a specified route or a known route. So if you don't have any route for specific traffic, you use the default route to reach the next hop. And how do you configure that? We configure that by using this command here. We go under the config mode and we do IPv6 route :/0. This means that it's going to match all the traffic. So all the traffic that you have will be sent there. And then you specify your next hop. Very simple. We're going to do it in a lab with some details. And then we are going to talk about network route. A network route is pointing to a specific network. Like you can see in the configuration, I specified this network here, the prefix 2001 colon 4 colon slash 64. This is a network, and I also specified the next hop. Yeah, this is very simple. So all the equipment on this network can be reached using this static route. Next we have a host route. A host route is pointing to a specific device. Instead of the whole network, you are setting a route to get to a specific device. This can be useful in many ways. Let's say you have many routes leading to a certain network and all the other traffic is using a certain path, but you don't want the traffic going to this specific computer to use that path, but use a different one. Then you can set a static route specifically for that device. And to do that, you do the command Ipv6 route. You specify your device that you want to reach. And if you notice, the subnet mask here is a /128, which means that we are matching all the 128 bit in this address. And this is the next hop where we are sending the traffic. All right, so next we are going to talk about floating static routes and what this is. First of all, I need to remind you of a notion that we saw with IPv4, which is administrative distance. What is an administrative distance? It's a number that is given to a route depending on how we know or how we learned the route. For every routing protocol or dynamic routing protocol, there is an administrative distance attached. For OSPF, for example, it is 110. For EIGRP, it is 90. And when it comes to static route, the lower is the best. So in this example, EIGRP is preferred compared to OSPF. So if we know a route through EIGRP and we know the same route through OSPF, or we know how to reach the destination through OSPF, the route that we learned from EIGRP is preferred. So when we have static routing, a static route has by default an administrative distance of 1, which means that with an AD of 1, it is preferred compared to all the other ones. So if we know a route, if we configured a route statically and we also discovered a new path using OSPF or EIGRP, the static route is going to be used. So then, what is a floating static route? A floating static route is a static route that you configured to back up your dynamic routes that you learned from a dynamic routing protocol. For example, if you want to have a route in case your OSPF doesn't find any better route to get to a destination, you're going to set a floating static route by changing the default administrative distance. So you configure it just like any other static route, IPv6 route 2001 and so on, and then you specify the next hop space, then you put the new administrative distance. Like in this case, we put 201. So this route will be floating on top of EIGRP or OSPF. So if we don't have anything with EIGRP or OSPF or any other routing protocol, we are going to use this static route. So it stays there in case there is no better route with a better administrative distance. So this is a floating static route. I'm going to show you how to configure it in the lab. The lab itself, this is what we're going to do. We have these different commands because Cisco wants us to know how to verify, how to configure and how to verify. So we have these two sets of commands. The first set is for configuration. Of course, IPv6 unicast routing to activate IPv6 routing on your router or your layer 3 device. IPv6 route :/0. This is a default route, so all the traffic will be sent to this router here. IPv6 route with a prefix or network sent here. This is for a network route. And the last one is for a host route. We have a /128 here. So we match all the 128 bits and we send it to this default gateway. This is just an example. And the last four are for verification. You can do show IPv6 neighbors to see exactly the table linking your link layer addresses to your global unicast addresses. I mean, your neighbors' global unicast addresses. We're going to check that as well. You can type show IPv6 route to see the different routes that you have on your routing table. You also can type show IPv6 route summary to give you a summary of the different routes that you have, or you can do show run to see the different configurations that you are running on your device. All right, without further ado, let's go in Packet Tracer, and we're going to spend some good time there configuring this topology here. And by the way, if you're watching this on YouTube, please don't forget to like the video to help the channel. You can also subscribe if you are an IT professional or if you like technology in general, because I share with you a lot of tech projects on this channel. So make sure you subscribe so you can get notified when I upload a new video. As I said, the goal is to make sure that we have connectivity between this device, these three devices. So what I'm going to do is I'm going to configure these routers to be able to route the IPv6 packet. So this one will have a default route pointing to the route number 2. So the route number 2 will be like our central router. It will be like a WAN. The router 3 will also have a default route going to the router 2. The router 4 will have a default route going to the router 2. But inside router 2, we're going to specify these different networks. So we're going to have a network route to point to this network. We have a network route going there and another network route running here. With this, we'll be able to ping across these different equipment that we have here. So let's do some verification first. If we look at this computer here, we go under IP configuration. You can see that I have the global unicast IP configured here. Of course, we have the link local, and I also have the IPv6 gateway already manually configured. I did the same for the other computers as well. I can come here in the router 2 and show you what we have. I already configured the IPs on all the interfaces. So show IPv6 interface brief. You can see that all the interfaces have IPv6 unicast global IPs configured. I mean, IPv6 global unicast addresses configured for the three interfaces that we have. And let me just test the ping from this computer to its default gateway. So let me make sure I can ping 2001:1. I can ping it without any problem. Okay, so let's move on with the configuration. First thing first, as I told you, we need to enable IPv6 routing in all these routers. So what we have to do is go in config mode and then do IPv6 unicast routing. As simple as that. That was for the router number 1. We do the same on router number 2. IPv6 unicast routing. Same with router number 3. Enable IPv6 unicast routing. Same with the router number 4. IPv6 unicast routing. Okay, so the next step would be, first of all, let me start some pings here. By the way, let me present you the different networks that I have. So I have a couple of networks here. The first network is here, the 2001:64. This is there, and then we have 2001:1:64. This is between these two routers, and then we have 2001:2, 2001:3, 2001:4, and :5. These are the networks that we have across this topology. Let me learn some pings from this computer. Ping 2001 going all the way to this computer here. :4, :11, and I need to make it continuous, so I'll put a -T here. Alright, right now it's unreachable. We can reach it. Our traffic at this time is coming to our default gateway and then gets stuck there. It doesn't know where to go. That's why if we do a trace route, I don't know if I've talked about trace route here, but I think we've used it before. So if I do trace route, instead of ping, I do trace routes you can see that I send the traffic to the default gateway and then it's lost. We don't get anything. So what I'm going to do is come here and set up a default gateway. A default route. So I'm going to do Ipv6 routes ::/0 to match all the traffic. I'm going to send it to this router here, which is 2001:1:2. 2001:1:2. All right. With this, if we do a trace route, we will still not receive anything from the second hop. Let's go. Yeah, so we reach 2001:1, but we don't have anything from ::2. From this one here, because it doesn't know where we are. So this is where I'm going to configure a network route to show this router where our network is. So I'm going to do Ipv6 routes and then put our network 2001:/64. Where are we located? We are behind 2001:1:1. So once I do this, this router knows how to respond. So if I do a trace route again, oh, you already saw it there. Okay, if I do this, you can see we reach the first router, the router 1. We then reach the router 2, and it stops there. Okay, let's go to the other routers as well and add default routes. So in here, I'm going to do Ipv6 routes ::0/0. Send it to 2001:2. Okay, ::2. Yep, that's correct. Same thing, we go in the router number 4. In the router number 4, we're going to do Ipv6 routes ::/0. We send it to 2001:3:2. Okay, at least we know how to respond. We send it to the default gateway, but I still don't have pings, and I know why. Because we don't know this network yet. Router 2 doesn't know this network here. So what I have to do is come in a router 2 and also specify the route going to the network. I think it's 4. Okay, we have Ipv6 routes 2001:4:/64. Send it to 2001:2:3. Look at this. Let's go back to this computer. Let me put this on top so we can see what happens when I make that change. So we are in a router 2 here. As soon as I click on enter, look, we have responses. We have replies from this computer far away. So what's happening now is that my this computer, PC0, sends the traffic to the default gateway. We use a default route to send it to the router 2. The router 2 uses a network route to send it to the router 3, and then the router 2 delivers the echo request. And then the reply comes from the PC1 to the default gateway. From here, we know what the default route is, so we send it to the router 2, and we use what we configured, like the network route, to send it to the router 1, and then the router 1 delivers the traffic to the destination. So that's what we did. That's why we have connectivity. Another thing that I can do for this computer here, instead of configuring network route, I'm going to configure a host route. So let's do this. So we have 5:12, and instead of 64, we do /128, and then the next hop is 3.4. So change this to 3 and change this to 4. Let's go back here. First of all, we don't have column 5, column 12. We don't have connectivity, but let me put this on top again. If I come here and I enter this command, which is a host route, we have connectivity. You can see the pings going to this you can see the pings going from this computer to this other computer here. And I can also ping from here. I can ping this computer down there, so I can go under the command line and ping 2001 colon 5 colon 12 without any problem. Let's do some verification. So if we are in a router 6, for example, the router 2, we can do show IPv6 route. Oh, neighbors. Let's start by the neighbors. Here you have the global unicast addresses, and you have the corresponding link layer address or the MAC address. You also have the interface or the outgoing interface that you use. And yeah, if I do show IPv6 routes, you can see that we have different types of routes. We have static routes. S stands for static. We have the connected route, which are connected. We have the local, which are local interfaces. This one is a local interface. This is a local interface. This one is, I think, is a multicast, but it's not useful in our situation. But yeah, the S are the static routes that we configured. You can see that this is the prefix. This is the administrative distance to reach it, and this is the next hop. Oh, talking about this, I can do it in a way that instead of having one here, I can have a different administrative distance, which is called floating static routes. So I can come over here. Let's see. Show run. Let's see what we have. Okay, let's take the last path here, the host route. I'm going to copy this. Conf t. No, I paste that command, so it's removed. And if you go back to the router, yep, there is no response anymore because the route has been removed. I want to change it. Put the same command, but set it as a floating static route instead of a regular static route. So at the end, I'm going to add 2000. If we do question mark here, AD is just 1 byte. So you have 1 to 254. So we can set 201 here. And then if we do show IPv6 route, by the way, we already have the responses or the replies here. So I'll show IPv6 route. You can see that we have this route, it's a static route, with an AD or administrative distance of 201, and this is the next hop. All right, I think that's pretty much everything for today. Of course, I'm going to give you a link to download this file. I'm going to give you the one that is not resolved, so you can work on it, and I'm going to give you the one that is resolved so you can know exactly what the responses are or how I configured it. And I'm also going to give you the link to read more on what I just talked about today from Cisco's website. And if you have any question, don't hesitate to go in a forum on KBTrainings.com and ask your question, or you can send me an email. I'll be glad to respond. That's it for today, guys. Thank you so much for watching, and I'll see you in the next one. Take care and bye.